There are three final examples that I want to give you before we conclude our discussion on loops. So, we're going to be using loops all throughout the semester. You're going to be using loops for as long as you're a programmer. So, if you don't understand loops, you need to understand them. I really encourage you to try, practice, ask questions, get better at writing loops, because everything we do for the rest of the semester will leverage on these things like conditionals, recursion, and loops. Chapter 2 is extremely fundamental stuff. Everything we do will rely on it. So if you're still struggling with it, please get help. Please, we want to help you. Okay? Now, the final three examples I want to show you are ways of working with loops in ways that you may not think are possible. So, in addition to looping upward, we can loop downward as well. And by that I mean instead of looping from 0 to the length of the string minus 1, we can go in reverse. We can loop from the length of the string minus 1 down to 0. Okay, there's nothing stopping us from doing that. So let's see. So let's write this little very simple method. I didn't write out the Java docs. You can assume what they are. Counts all occurrences of the char S in the char C and S. So very, very simple thing. We've done this before. In fact, we literally have it over here. But let's say we're going to do it from right to left. So we're going to have a counter, ACC equals 0. Return the counter. Doesn't matter what you call it. Well, it matters, but for the sake, we'll just say it's the accumulator. So we're going to loop from not I equals 0, but I is equal to s dot length minus 1. Why is it s dot length minus 1? Because if we started at s dot length, we'd already be off to a bad start. We'd be out of bounds. Okay? So we want to keep looping as long as I is greater than or equal to 0. So as soon as I is less than 0, we're out of bounds, so we break. Okay? And then instead of doing I++, we're going to do I minus minus. Okay? So we're going to be going down from the length of the string rather than up from 0. Okay? And then, okay, now my cat's in my lap. Hello. And now she's gone. Okay. So this is extremely easy. So all we have to do is just say if s.char of I is equal to C, ACC, we could do plus equals 1, we could do ACC equals ACC plus 1, we can also just do A++. Okay? And then we're going to return ACC. Okay? I don't have any tests written because I just thought of these three examples, but hopefully you can see why this would work. And if you don't believe me, then pretend I asked you to do this yourself. Write the tests, write the documentation, write the method, or rather just copy the method, test it, you'll see it works. Okay? The next example is we can actually do things like we can count in increments. So we don't just have to go up by 1 or down by 1. We can go up in any interval we want. Okay? So in this example, we're going to write a method called countByN that returns the sum of the integers from 0 up to v incremented by n. So for example, again, I don't have tests written, but countByN of 14 and 3 would return the sum of 0 plus 3 plus 6 plus 9 plus 12. It wouldn't include 15 because that's not the next multiple of 3 would not be it's not less than or equal to our value v. Okay? So, again, we'll just have a counter, or return, or not a counter, a sum tracker. So, then we're going to do for int I equals 0. And let's think about our condition. So in this case, we actually want it to be less than or equal to v, because we're not traversing over a data structure or a collection or a string with indices. So if we did this, so this actually really depends on how I state the problem. So I really should probably say inclusive. If this were exclusive, then this would return the same thing. If this were inclusive, this should return 15. Okay? So it's always important to read the problem or to ask questions if you're confused, because this is something that, like, if I just omitted this, it would be it'd be completely ambiguous. Okay, so always ask questions if you're confused or you're not sure about the clarity of a question. Okay, but because we're going to say that this is inclusive, then we're going to do less than or equal to v, and then now instead of doing I++, we can actually hop in increments of n. Okay, so I plus equals n. So the value of I will be 0, I plus n, I plus 2n, I plus 3n, I plus 4n, dot dot dot, up until we get to the bound. Okay, so let's do that. So we're going to do ACC plus equals I, and then we're done. That's it. Yeah, so very simple. Okay, again, write tests to see that this works. Okay, final thing I want to show you. Loops can have, loops can be nested. Okay, so you can put conditionals inside of loops, you can put recursive calls inside of loops, but more, I guess, not importantly, but more prominent for this example, loops can be inside of loops. And this is where a lot of people can get kind of confused. So let's write this method that's called mult, that says returns the sum of the products of all the integers from, this is kind of ambiguous, but the idea is that it's going to return, so we're going to assume a is less than b, but it's going to return, so for example, if mult were 3 and 5, it would return the sum of the values 3 times 5 plus 4 times 5 plus, let's see, how do I want to phrase this? Sorry. No, that's not right. So it'd be 3 times 3 plus 3 times 4 plus 3 times 5. Then it'd be 4 times 3 plus 4 times 4 plus 4 times 5 plus 5 times 3 plus 5 times 4 plus 5 times 5. Okay? So hopefully you can see why this makes sense, or like how this might work with two loops. Okay? One loop is going to govern this value, and the other loop is going to govern this value. Okay? So let's line break this just to make it a little bit more obvious. So for we're going to loop from, let's see, how do I want to phrase this? We have an outer loop that governs the right digit, or sorry, the left digit, and then, or the left number rather. And then we have an inner loop that governs the right one. Okay, so how do I want to say this? So first of all, let's have another accumulator, and then we're going to have a for loop. So we're going to say for int, let's say I is equal to a. So we're going to start it off at a. Okay, and then I is going to be less than or equal to b, and then I plus plus. Okay, and then inside of here we're going to have another for loop. So we're going to say for int j is equal to a, j is less than or equal to b, j plus plus. Okay, so this one's a little bit, this is not the greatest example in the world. In lecture I'll probably give a better example, but the idea here is that how is this going to look? So let's just write the code, and then let's do the, let's run the debugger, and we'll see how this works. Okay, so it's going to be the sum of products, so we're going to do I times j, and then we're going to return ACC. But I want to debug this, so let's create a test. We'll test mult. So do as I say, not as I do. Write the tests before you write the method. So what is the sum of the products from 3 to 5? I actually don't know. Let's see, loops.mult 3 to 5. But I want to debug this to show you what's going to happen. So let's run this with debugging. So we're going to get into here. Let's step into it. Step into mult. Okay. So A is B, 3 is 5. Or A is B, 3 is 5, yeah. A is 3, B is 5, yes. Okay, so let's step into the loop. So now I is going to take on the value of A. As long as I is less than B, we're going to continue, then I plus plus. So then inside of here, we're going to say J is equal to A. J is less than B, J plus plus. So now let's see the values of A, B, I, and J. So A and B, of course, are going to stay the same. Okay, so we're going to do 3 times 3, and then we're going to increment J. Okay, so then we're going to get 3 times 4. Okay, then we're going to get 3 times 5. Okay, and then now J is going to be 6, and then that's going to be greater than B, so we break out, and then we come back up to the top. Okay, so actually it's more like we went down to the bottom than jumped back up, but I got incremented to 4. Okay, so as we see, I became 4, we check the condition, and then we start over. Okay, this loop starts back over at 3. Okay, so now we're going to do I is equal to 4, J is equal to 3. Multiply that, J is equal to 4. J, and if you're wondering why I'm looking to see that, it's down here. It is kind of small, so you might need to zoom your eyeballs, I guess. I don't know how to make this bigger. But also you can see it like here. So everything that I'm doing here is also visible up here. So you can see the value of ACC, the value of I, the value of J, the value of A, the value of B. The IntelliJ debugger is amazing, so take advantage of it. Okay, so we get to I equals 5, I equals 6, then we jump out. Then we do it again, so now I is equal to 5. Keep going, keep going. So we do. So again, we're just following exactly this pattern. So 3 times 3, 3 times 4, 3 times 5, 4 times 3, 4 times 4, 4 times 5, 5 times 3, 5 times 4, 5 times 5. Then we're done. And now I is equal to 6, so we jump out. We go down to the return value. That is 144. And of course, the assert equals fails because I don't know math. But yeah, so nested for loops are going to be very common. They're very common in the real world. They're very common in this class. So it's important that you know how they work. It's especially important that you know how they work for next week's material. Okay, so there's one particular application where 2D for loops will be extremely necessary. Okay, so learn them, study them, analyze them, all that good stuff. Okay, there's one more example that I want to show off. So let's say that we want to break out of a loop early, or we want to stop doing whatever we're doing and go to the next iteration of a loop. So let's say we have, let's just say we have a method foo that receives 2 integers, int A and B. Let's say we have a loop that goes from I equals 0 up to, but not including, I is equal to 100. Let's say that if, I don't know, if B is equal to 40, or sorry, if I is equal to B, then we want to stop what we're doing. We want to break out of the loop. We don't want to go any further. Okay? And if, let's say, well, let's do it like this. So if A is equal to I, or I is equal to A, that doesn't matter, then let's say we're going to continue. So these two keywords, they mean, I don't know if I've explained this in a previous video, but continue means that we're going to go from here, and then we're going to jump back up to the top of the loop. Okay? So we're going to evaluate this stepper expression, and then we're going to, well rather, we're going to evaluate the stepper expression, and then we're going to reevaluate the condition. So if we see a continue, we're going to run this, and then we're going to jump back up to the top and rerun the condition. Okay? If we see a break, on the other hand, break is actually much simpler. If we see a break, we just jump out of the loop. We're done. Okay? And if we were to see a break somewhere in here, like let's say if ACC were 150, we break, the break only applies to the inner loop. Okay? So if we break out of here, that would actually just put us down here, and we jump back up to the top here. There is a way to break out of multiple loops at once, but that's very bad practice for most intents and purposes. So don't worry about it. If you want to know about it, you can look it up, but there's never going to be a need to do that. And if you do think there's a need for it in this class, you're probably writing incorrect code. Okay? But there are also better examples of break and continue in the book. So if you're curious about that, I would encourage you to look at them. But very rarely, if anything, in this class will require the use of break or continue. Okay? All right, so those are loops.